Hey there, Mr. Rising, once again with the American flag right over there and the UAS banner here, so I'm practicing with my camera. Anyway, hi. This lesson is about the fundamental nature of what algebra is taking a process and putting an unknown quantity through it. And what's so amazing about this is we can build things and test different ideas that all pass through the same process. And that's this idea of what a variable is and the expression. So the variable is the quantity that we're going to pass through something. The expression is the instructions on how to do it. So just to review some vocabulary, math has a lot of vocabulary in it. A variable is a letter or symbol used to represent a value that can change. That's thinking my quantity. A constant is a value that does not change. A number, such as the number 9, the number 3,718. These are constants. The slope of an expression. These are things that do not change, considered constants. Now, a numerical expression contains only constants and operations. 3 plus 4. An algebraic expression may contain variables, constants, and operation. 3 plus 4 divided by x would be an example of an algebraic expression. So things you're familiar with, but this is what we see in math. This is what we see in the real world. So when we think of this symbol, the plus sign, of course we think plus, addition, combine by adding, right? Sometimes we think of that as sum or a value increased by. Some value increased by 3, x plus 3. When we talk about this symbol, we think minus or difference or less than. So some value less 7, right? X minus 7. Sometimes you'll see multiplication as a little dot between things. Or this symbol on a computer, this would be like shift 8, or you see the traditional X. So of course that's times the number of equal groups of the same, or the product of two values together. Of course you're familiar with long division. Sometimes it looks like this on a calculator. On a computer it's this slash, and it's the same thing with a fraction. 3 divided by 4, 3/4. So that's divided by, or the quotient. When you write these, write this expression, 2 times y. All of these here are the same thing as 2 times y. 2 times y. 2 times y. Now this isn't 2, the variable x, the variable y. They're saying 2xy. There's my phone ringing. I'm going to pause for a moment. Hey, that was an important phone call about an upright freezer, so I'm going to have to make this lecture really quick, or I'll have to pause it and do it several times. All right, example. Translate from algebra to words. Give 2 ways to write each algebraic expression in words. Go ahead and try this now. Pause the video. Okay, welcome back. 9 plus a, the sum of 9 and r, right? Adding the two things, or 9 increased by r. This one over here, well, based on these patterns, you'd say a value less 3, q less 3, or you could say the difference of q and 3, or 3 less than q. Here's some other problems. Give these a shot. Give 2 ways to write these expressions. Go ahead, pause. All right, welcome back. Of course, 4 decreased by n, or n less than 4. Over here, you've got t divided by 5, or the quotient of t and 5. Can I do this? There we go. Of course, you'd say the sum of 9 and q, or q added to 9. Now this one, the product of 3 and h, or 3 times h. When we translate words, so real-life things, into algebraic expressions, look for words that indicate the action. So again, when you think of adding, or when you hear put together, combine, you think adding. When you think find how much more or less than, you're probably going to be talking about subtraction. Putting together in equal groups, of course, is multiplication, and separating into equal groups means to divide. So go ahead and try this right now. All right, what did you come up with? Roberto is 4 years older than Emily, who is Y years old. Okay, so Emily is Y years old. Write an expression for Roberto's age. Emily is Y years old. Roberto is 4 years older, so Y plus 4. Try this one. Pause. Okay, what'd you come up with? So if Lou drives at 65 miles per hour, write an expression for the number of miles that Lou drives in T hours. Well, if he drove 0 hours, he would have gone 0 miles. If he drove 1 hour, he had gone 65. Oh, so equal groups of 65. That must be 65 T. Does this make sense? I hope you're feeling pretty comfortable with this. Of course, we can talk about it together. I'll give you some practice problems to go on as well. All right, to evaluate an expression means, hey, take these numbers, all right, and plug them into the expression. So you've got a variable in your expression. Now we're going to plug values in and evaluate the expression for several different things, like I did with the driving. 0 hours, 1 hour, 2 hours, etc. So evaluate each expression for A is 4, B is 7, and C is 2. Okay, well, let's substitute. 7 for B minus C is 2. 7 minus 2 is 5, right? You get the idea. Simplify. Go ahead and try this one. What does this mean? Pause. Okay, this says A times C. So let's substitute 4 for A, 2 for C, and of course 4 times 2 is 8. Simplify. Try a different problem here. M is 3, N is 2, and P is 9. M times N, of course, 3 times 2. Substitute and simplify. 6. Now P minus N, of course. Pause. All right, what you come up with? P is 9. N is 2. Substitute. 9 minus 2 is 7. Ooh, one more. P divided by M. Sometimes this gets confusing switching it with a division bar, but just do it straightforward. 1, P is on top, M is on the bottom. 9 divided by 3, right? Once we substitute. And of course, that's 3. A replacement set is a set of numbers that can be substituted for a variable. So again, when you evaluate an expression for these numbers, 20, 50, and 325, you're going to get a different answer for each one. Let me show you a different example here, and we'll try it. So the problem states to make one sweater, 63 20-ounce plastic drink bottles must be recycled. Write an expression for the number of bottles needed to make S sweaters. Okay, so if I'm going to make one sweater, I need 63 20-ounce bottles. If I want to make 2 sweaters, I need 63 times 2. So here you think about it, you're like, oh, here's my expression. 63 times S, the number of sweaters, 1, 2, 3, 4, 5, etc., whatever, times 63 20-ounce plastic drink bottles. So find the number of bottles needed to make 12, 25, and 50 sweaters. So when they say find the number of bottles, they mean evaluate the expression. And of course, when you go ahead and do that, 12 times 63 is 756, 25, and 50. I hope this is a good introduction to what variables are and expressions. We're going to do some more work together. If you're feeling comfortable with this, go on to the next video and we'll take it from there in class. Or if I assigned you some problems, try those too.